So, hey, buddy, welcome back to the series named In the Search of Shooting a Cat, in which we talk about the quantum mechanics in a form of a thriller story by which you can easily understand that why are we saying this, and how this happened in the past, and how this changed the present of quantum mechanics on quantum world. So, be with me in today's thriller story named Superconductors. So, be with me in the story. I hope you enjoy. So, start with this. A laboratory was eerily silent, save for the occasional hissing of liquid helium as it boiled into an eternal mist. Heike Kamerlingh Onnes, a man obsessed with the secrets of the universe, learned over his instruments. The mercury thermometer tipped below 4 Kelvin. And what happened next would change physics forever. The resistance was gone, no reduced, no minimized, vanished. Zero. It was as if the electrons had ceased to acknowledge the rules of conventional physics. Electricity flowed without hindrance, without heat, without loss. The world had just entered the domain of superconductivity. As the news spread, scientists scrambled to make sense of this phenomenon. Even Einstein was puzzled. The thrust there must be an explanation. He must. But none emerged. Superconductivity remained an enigma, a glitch in the otherwise predictable classical world. Decades passed and the mystery deepened. The classical laws of physics failed to explain the bizarre nature of superconductors. It was the 20th century. A new language had begun to shape reality of quantum mechanics. Okay, Richard Feynman, the greatest scientist of all time in the quantum mechanics, you know, and I know all of them. Okay, so he said the matrix physicist who played with the very threads of reality once said, "I think I can safely say that nobody understands quantum mechanics." And yet, this unfathomable science had the key to unlocking superconductors' secrets. Enter Braden Copper, enter Braden Copper, Schiffers, the trio that cracked the code in 1957. The BCS theory unveiled a truth more bizarre than anyone had expected. Electrons, which were supposed to repel each other because they have negatively charged energies, were forming pairs, copper pairs, and together they were slipping through barrier as if they were ghosts passing through walls, like they are behaving like a ghost particle passing from any resistance without any resistance fields. Okay, so they are not losing energy, they are not like any change in them, they are just moving from resistance like a ghost. Okay, this was a quantum tunneling in action. They are passing from one place to another in the seconds. Okay, the room is silent save for the low hum of an experiment in process. Liquid helium swirls in its chamber, mist curling like ghostly finger around the instruments. Dr. Owens watches the thermometer dip below 4 Kelvin. The wire submerged in the coolant shudders slightly. And then something impossible happens. The resistance drops to zero, not reduced, not minimized, zero, gone, vanished. Electricity flows freely without friction, without loss, like it have no resistance anymore. The world had just entered the quantum realm. Heike Kamerlingh Onnes handles tremble as he notes his observation. He does not yet know it, but this moment will change the course of physics forever. Be with me. Superconductivity, an unexplainable anomaly in the classical world. Scientists scramble to understand why it exists. Even Einstein is briefly muttering, there must be an explanation about this. The decades roll by, and yet the secret remains buried in the mysteries until quantum mechanics emerged. and a change happen, revealing the hidden order within chaos. Inside a superconductor, electrons behave unlike anything seen before. Listen to me carefully. They form pairs, copper pairs, moving in perfect synchronized harmony. These pairs do not collide, do not resist. They slip through obstacle like ghosts walking through walls. I explained in the past few seconds, okay? They are behaving like a ghost particle. They not feel resistance, they not feel friction. They move freely. They exist in a quantum state, a dense decade dictated by the unseen laws of the universe. Breeding, copper, and centrifuges finally cracked the code in 1957, unveiling the PCS theory, the key vibration, phonons whispering between electrons, guiding into them pair. And once paired, they obey different rules, quantum rules. Suddenly, a whole new realm of physics open up. A realm where superconductors unlock limitless potential. A realm where wires carry electricity with no heat, no energy loss, no friction, man. The world races to harness this airy power. MRI machine emerged, probing the human body with superconductor magnet. Train levitates, gliding frictionless over superconducting tracks. Superconductors began whispering to computers, the birth of quantum computing. In the heart of quantum processors, superconducting qubits defy classical logics. They exist in multiple states at once, like solving problems in an instant. They hold the key to artificial intelligence, cryptography, space exploration. And yet, the strangest discovery is still ahead. In deep space, scientists find evidence that superconductivity may be woven into the universe itself. Could space-time, the fabric of existence, be superconductive? But the search for room temperature superconductors intensifies. If unlocked, they could power the world with infinite efficiency. Cities would glow without a single watt wasted. Spacecraft could launch without fuel. The very structure of reality could be rewritten. But with every answer comes another question. If superconductor can bend the rule of reality, what else they can do? Could they be the key to understand continuous consciousness itself? Could they reveal dimensions beyond our precisions? The superconducting revolution has only just begun, and the world is not ready for what come next. Meanwhile, a deeper realization was setting in. If superconductor operated beyond classical physics, listen to me. If superconductor operated beyond classical physics, then perhaps they were the bridge to something even stranger. And the name is quantum computing. In The Search of Schrödinger Cat, John Graben explained how quantum mechanics has reshaped our understanding of reality. The infamous cat neither alive or died, the perfect analogy of what superconductor were now enable, enabling inside the quantum coherent state. Electrons exist in a superposition, both flowing, not flowing, both colliding and passing through barriers. Okay, this was the foundation of quantum computers. Instead of bit flipping between 0 to 1, 1 to 0, qubits could exist in multiple states simultaneously. Today, the world terrors on the edge of a new scientific revolution. High temperature superconductors, once thought impossible, are begin a reality. The dream of world powered by lossless energy, of floating amalgam trains, of quantum cryptography is no longer science fiction. It is unbeatable. But with great powers comes an uncertainty, not great responsibilities. But in a quantum language, it comes with great uncertainties. The only certainty is this: superconductors are not just material, they are keys to the quantum world, and their journey has only just begun.